Hi, today we're going to talk about the kinetic energy problem set 1 worksheet. You've gone ahead and written the equation up on the top of the sheet. Kinetic energy equals 1/2 mv squared. For this worksheet, we're going to use the guess method to solve for the following problems. Remember that the guess method means given, unknown, equation, substitution, and solve. Don't forget to include your units in all your steps. Number 1. Calculate the kinetic energy, so that's what we're looking for, of a 3 kilogram toy car that moves 4 meters per second. So I have my kinetic energy, which I'm looking for, my mass, which is 3 kilograms, and my velocity, which is 4 meters per second. I'll write down my equation, KE equals 1/2 times m times v. I'll plug in what I know, 1/2 3 kilograms times a velocity of 4 meters per second. Now these equations are a little bit different than in the past depending on how you want to calculate them with your calculator. I know not everyone in the class has the same calculator, so I'm going to try to make this as simple as possible. Oops, I forgot to do my squared right here. Okay, so what I mean by that is I'm going to go ahead and do 4 squared first. So I can go ahead and do 4 times 4 to get 16, or I can do 4 with this key here to get 16. So it's up to you. I might even go ahead and take that step to write in what that is first. So that step of the equation is done. Sometimes calculators do them a little bit differently, so we want to make sure we're all on the same page. So I can take that 16 and I'll multiply it by 3, and then I can multiply it by 1/2, or just simply 0.5. And when I do that, this equation will give me 24. Again, we're dealing with an energy, so that is going to be in joules. And that's number 1. Let's go ahead and try number 2 together. It says calculate the kinetic energy of the same 3 kilogram toy that moves at 8 meters per second. So I'll write in what I don't know, which is kinetic energy, and what I do know. So again, it's 3 kilograms, and my volume is going to be 8 meters, I'm sorry, not volume, my velocity is going to be 8 meters per second. So here I have kinetic energy, 1/2 times m times v squared. Oops, I should probably do meters per second. Squared. So I'm going to do that again. I'll do 8 to the second. It's going to give me 64. Multiply that by 3 and multiply that by 0.5 to give me 96. 96 what? 96 joules. I'll square my answer. Now I can do number 3. A greyhound can reach speeds of 16 meters per second, or 36 miles per hour. What is the kinetic energy of a 20 kilogram greyhound when it gets to this speed? So we're going to use that speed. I like that speed because that's the units that we've been working with. I don't know my kinetic energy. I do know my mass. Here we go. 16 meters per second. And I can go ahead and plug this in. So kinetic energy equals 1/2 times 20 times 16 meters per second squared. I'll go ahead and square 16 to start, multiply that by 20, and multiply that by 0.5. So 2,560, of course it's in joules. Now we'll go ahead and work on number 4, which might be a little bit trickier. Frank, a San Francisco hot dog vendor, has fallen asleep on the job. When an earthquake strikes, his 300 kilogram hot dog cart rolls down Nob Hill. How fast is his cart going? So how fast is his car going when his kinetic energy of 15,000 joules reaches at the bottom of the hill. So I'll write in what I know. I know my kinetic energy at this time, which is 15,000 joules. My mass is going to be 300 kilograms. And my velocity is what I'm looking for. So I'll write in my equation, KE equals, I'm sorry, I messed that up. Well, I'll write my equation in first. So KE equals 1/2 mv squared. I know my KE, which is 15,000 joules, 1/2 times my mass of 300 times v squared. Okay. So I'm going to combine these, so I'll do 1/2 300 times 0.5 is going to give me 150 kilograms. Is 1. Okay, now I'm ready to divide each side. So I'll do divided by 150 kilograms, divided by 150 kilograms. You could figure this out on your own, but I'm going to go ahead and put it into my calculator in case people aren't too confident with their math skills. Which is going to give me 100. Is that right? Yeah. Let's not worry about those units at this point, since we're just going to use the unit for a velocity anyway. So, are we done? Not exactly. We have to go ahead and find the square root of these. So I can take that 100 and hit this button right here that looks like the square root symbol, and it's going to give me 10. 10 what? 10 meters per second is equal to my velocity. And that is number 4. Last question is number 5. The 1987 Kentucky Derby winner, Alysheba, ran the race with an average speed of 15.85 meters per second. What is Alysheba and her jockey, Chris McCarron, combined mass if they had a kinetic energy of 69,100 joules as they go across the finish lane? So we know our energy, we know our speed, but we're looking for this mass. So Alysheba is the horse and Chris McCarron is the jockey, so we're talking about together. So this is kind of tricky in the sense of thinking about that these are two things that are coming together as one. So I'll write down my my unknowns and my givens. My unknown is my mass, but I have my kinetic energy of 69,100 joules, and I have my velocity of 15.85 meters per second. So I'll write in my equation, and then I can go ahead and substitute. So I'll do 69,100 joules is equal to 1/2 times my mass times my velocity. I'm going to go ahead and square this number to start out with. 15.85, and I'll use that squared key right there, squared. And I'm going to round this. Then I can go ahead and multiply this by 1/2 to give me 120, let's say 126, because we'll round up there, times my m. And now we're going to divide by each side. So I'll do my 69,100 divided by 126, which is going to give me 548, which is going to be equal to my mass. It will be in kilograms. So square your answer, and you're all done with the worksheet.